Okay, that got cut off kind of quickly. So I hope you understand angle bisectors are the incenter when they meet. So the POC, or the point of concurrency of angle bisectors, is an incenter, and it's always equal to the sides. Equal, equal, equal. Not to the vertices, to the sides. So on to the next page is some examples. I'm going to pick and choose a couple here. The first one says find BF. So the first thing we want to look at on BF, I noticed that this is 19 and this is 19. So that's an isosceles triangle. This is perpendicular here. These triangles have to be congruent because we just learned that when you have isosceles, these angles are congruent, which means this is a perpendicular bisector right here. So BF has to be 4.2. The next one, there should be an angle there. I don't know why there's a box. If you look at your picture, yours should be better than mine on the screen. Right here we see 90 degrees. We see these are equal distance. That means that this must be an angle bisector because those distances are congruent. So to solve for x, we're going to set 7x plus 5 equal to 3x plus 21. So when you solve that, 4x plus 5 is 21. Subtract your 5. 4x is 16, so x has to be 4. The next one over here says CDF is equilateral. Remember, that means equal sides. It also means equal angles. And because they're equal angles, remember that all angles are 60 degrees. So when I look in here again, I see that this line comes in perpendicular. I see these markings, which means it's a perpendicular bisector. So this is a 90 degree right here. To find x, we would add 3x plus 6x. You could add 90 to equal 180. Or you could just add 3x and 6x to get 90. Either way, 9x is 90. X equals 10. To find your y, you would just set those two segments equal to each other because that's a perpendicular bisector, which bisects both sides. So negative 2y is negative 4. Divide, y equals 2. So in the next section, it talks about a circumcenter. So the first thing I want you to start thinking, okay, what is a circumcenter? You got to start memorizing that. You only have 2 on these notes. A circumcenter is the point of concurrency of perpendicular bisectors. And then there was a theorem also. Circumcenters are equal to the vertices. So remember, this is something you want to start to remember every time you see a circumcenter. So this says, list any segments congruent to the segment below. So when I look at this picture, I can mark up a few things. If P is the circumcenter, I know this is congruent to this because that's a perpendicular bisector and I see my 90 degrees. I know MN is congruent to NK because that's a perpendicular bisector right there. I also know that RK is congruent to ER because that's a perpendicular bisector there. And then I know one last thing. It is P is equal to the vertices. So if I want to draw it in, P to M, P to E, and P to K, those are all equal also. So make sure you realize all that. Now we can say, okay, MY has to be congruent to EY. KP. KP is congruent to two segments. It's congruent to MP, and it's also congruent to PE, to the vertices. MN is congruent to NK. And ER, the ER, never want to go there. ER is congruent to RK. Now you know all that because you know what a circumcenter is. So make sure you know these little tricks to what a circumcenter is. Now that being said, the next one here says point U is the incenter of this triangle. So an incenter is different. An incenter is formed by angle bisectors, and an incenter is equal to the sides. Incenters are equal to the sides. Now I know you're just learning this, so you want to learn and memorize it. Before I go over to that picture there's an 8 here, and I believe this is an angle, this is an angle. So, when I look over here, here is U. U appears to be that point of concurrency of your angle bisectors, because it says U is an incenter, so I can come here and I can mark these congruent, these two angles over here congruent, and the two angles at the top are congruent. Knowing that, when it asks me what MU's measure is, MU is equidistant to the side, so I'm going to use this pink. So this is equidistant to this right here, which is equidistant to this over here. So MU equals 5. Hope that makes sense to you. Angle UGM is 28. Angle PHU is 21. And HU, when you look over there, HU, I'm going to grab purple. HU is this line here. Now to find HU, we don't have much information because an incenter is not equal to the vertex. So this is where you have to be looking for other contents clues, like right here is a right angle. So this is a right angle right here. I'm going to pull this triangle out, and it looks like this. And hopefully, since I now wrote that there, you're thinking that is a right triangle. And in right triangles, I mentioned on the other video of Pythagoras' theorem. So we're going to make HUX, and that is the hypotenuse. So to figure this out, we would do 5 squared plus 12 squared is x squared. 5 squared plus 12 squared is 169. The square root of 169, it's a perfect square, is 13. Now that's a popular one. Try to memorize that. When it's 5, 12, there's a 13. So HU is 13. So take a minute to think about that. Hopefully that makes sense to you. Oh, let's see. Am I going to do these ones? I'm going to skip these ones for now because they're basically the same thing. I will post the answers to these if you want to try them later. But let's try a few on the back because I'm getting short on time again. Let's switch this over. It says Joanna has a triangular lawn. She buys a water sprinkler. So here's her lawn. It's a triangle. I don't know who has triangular lawns. But anyway, she buys a water sprinkler. If you were here in class, I'd do like the water sprinkler dance, but you're not here. Okay, she buys a water sprinkler to water the triangular lawn. The sprinkler needs to be placed on the lawn so it is the same distance from the vertex. Okay, so we talked about this today. Same distance from the vertex. Where should it be located? There's only two places. We learned circumcenter and incenter. So if it's from the same distance to the vertex, hopefully you realize that has to be the circumcenter. 16 says, Marcia and Bill are going to the park for a picnic. Here's another triangular park. Parks sometimes are triangular. One side of the park is bordered by a river. Here's the river. The other two sides are by busy streets. Marcia and Bill want to find a spot that is equally far away from the river and the streets. So if it's equal from the river, which is here, and the streets here, that is the incenter, because it's equal distance to the sides. Okay? Two last ones we want to do with you real quick. I know this has been a long list of notes. I'm trying to go slower because I'm not here with you. Number 17, it says, what is the value of x that makes G the incenter? All right, you're going to hear me say this again. Incenter. Incenter is angle bisectors. Angle bisectors, incenters. What are they equal to? They're either equal to the vertices or they're equal to the sides. Angle bisectors, incenters are equal to the sides. So when we look, this G is equal here, down to here, and over to here. I know you don't know what here is, but hopefully you looked up there. GS, GT, and GR are congruent. So we need to find this value of x that makes these three lines congruent, but we don't have measurements there. So there's two choices. Well, there's actually only one choice. Right here I see a 13. Right here I see a 12. Right here I see a right angle. So you always want to be looking for those right triangles so you can find sides of them, because in this case, that's a leg. And there's that 12 and that 13 again. So when you use Pythagorean's theorem, you're going to do x squared plus 12 squared is 13 squared. X squared plus 144 is 169. Subtract 144. X squared is 25. X equals 5. So, 5, though, is not the answer because that is the measurement of all these lengths. Whoa. So we set x minus 3 equal to 5, and we're going to get 8 for your answer. I hope this is clicking, making sense. You might have to watch it again. And then the last one here, I'm just going to do this real quick because I'm down to a minute and a half. We have perpendicular bisectors. Perpendicular bisectors is a circumcenter. So point A is your circumcenter. And you have to remember circumcenters are equal to the vertex. So here's your point. I see that this out to here is 24. And this to here is 8x plus 16. So if I set 8x plus 16 equals to 24, I can find x. Let's try to find y. Right here is where y is. Y is 5y minus 6, and that equals 24 again, because it's equal to the vertices. And the last one I need to find is this z. And because this is a perpendicular bisector, to find z, I would set 7z equal, not 7z, 7z plus 4 equal to 18, and solve. So I'm going to post this on Thursday. The sub hopefully will play it on Friday. Make sure you get a note sheet from me and you copy these down. The homework will be posted and due on Monday. and I'll review anything that you have a question.